So this is STM32L476 Discovery Kit. You will get this in this plastic uh, package with all these information written on it. So, and you open this package sideways. Okay, then you will present it with this board. Okay, so this board, on the top you have right about here, it is STLink V2 built right into this board, and this board also, so this is the main STLink chip. This board communicates with your PC through this USB port. It is a mini USB port. And here, so this is a mini USB port, and there are some things on top of this board, like these are the jumper for different, if you want for different combinations for this STLink V2, whether you want to program this microcontroller or you want to program some other ST microcontroller using these pins. These are your pins for programming. Okay, then we have this reset. It has to be, if you want to power this STM32L476 microcontroller using the power from this section, so you have to enable this jumper. This is the for reset, and then this block is for if you want this board to communicate with the outside, with some external peripheral, so you can do this by using this port. This is an I2C extender. Okay, so as you can see, this is an I2C extender. Okay, then we have couple of LEDs. So this is the main LED which you will be using for programming. Okay, so when it is supplying power to this board, then it will be red, but if you upload something from your computer to this board, then this will change color. Okay, it's a multicolored LED. Then we have a very small LED. Just about here. Then we have a small LED. This is for if this board draws out any overcurrent, then this will light up. Okay, this board does not have any so this is the low power microcontroller. So this board does not have any external crystal or any type of oscillator or resonator. So this microcontroller generates its clock signal internally using a combination of RC circuit and PLLs, and it can achieve that very accurately and up to 80 megahertz. Okay, so you get a LCD screen. Its controller is built into the microcontroller itself, so there is no additional hardware. This chip is measuring this microcontroller's current draw. So this is from ST itself. So, and then we have different this joystick. It's a 5-way joystick with the center tap and 4 directional clicks. This is the reset button, and then we have a 3.5 mm jack for the DAC. This is the DAC from Cyrus, and this is a 16 megabyte memory. Okay, then it also has a mic, and there is a one MEMS sensor for compass. It is hidden behind this it is hidden behind this LCD screen, so if I lift it up, then you can see it. There are two there are so if you want a very highly accurate and precise clock signal, you can add a external crystal to it. There is a place, but they haven't included on the board. There are a couple of jumper wires. So this jumper, which this chip used to power it on, so you have to always connect this. So you can also measure this current draw using these jumper wires. So this on the black side, you can see there is a battery compartment. It uses CR2032 battery, and there are many ground standoff for your signal measurements. Okay, there are quite a few. So here we have 8 standoffs for ground, so you can measure different signals. So this socket is for measuring is for your battery, and this jumper enables your battery. You can either have your board powered up using the USB power, or you can have your board powered through this battery connector battery. So this is a 3-volt battery, and from the USB it gets about 5 volt. This chip has an internal SMPS, which and this board also has an USB, since this microcontroller supports USB OTG. Okay, it's not the full spectrum, but OTG, and these are some pins for measuring the signals. There is not much that is free pins over here. So if you want to use this microcontroller, you have to select accordingly, and there are almost none that is free on this board. Okay, that's it.